This week, we're going to use analysis of variance to compare means again, except this time we're going to be looking at 3 or more groups. This past spring, I was lucky enough to get to the Brooklyn Botanical Gardens while the cherry blossoms were in bloom. And I noticed something very interesting. They filled an entire field with these beautiful cherry trees. And there were just so many of them, and they were so close together that it was hard to distinguish the blossoms from one tree from the blossoms from another tree. There were a variety of trees that were present at the Brooklyn Botanical Gardens. Some of the trees were wide and very full of blossoms. Others of the trees were much narrower. And I noticed that if the trees were very wide, if the blossoms were really spread out, that in order to be able to distinguish between individual trees, the tree trunks had to be very far apart. On the other hand, if the trees were very narrow, the trunks didn't have to be that far apart in order to distinguish between individual trees. I further noticed that the trees were symmetrical. The trunks were in the middle of the trees, and more of the blossoms were towards the center of the tree, fewer were far away from the tree. I realized that there's something else that has those same characteristics. I look at the normal distribution. It's bell-shaped so that the center is in the middle of the distribution, and more of the values are close to the mean, fewer are further away from the mean, and it's symmetrical. Here, we see 3 groups represented on the top and on the bottom. The variability is the same for all of these groups. On top, the means are close together, so it's hard to distinguish between the 3 groups. On the bottom, the means are further apart, making it easier to distinguish between them. Here, the means are the same, but the variability for the groups on the bottom is much smaller. So, even though the means are the same, we can distinguish easily between the 3 groups in the bottom set. Let's create a new statistic that we're going to call f. F is going to be the ratio of 2 numbers. On top, the numerator is going to be the variance between the means in several groups. The larger the variance between the means of the groups, in other words, the further apart the means are, the larger that ratio f is going to be. On the bottom of this ratio, we're going to put a number that represents the variance within the groups. As the variability within the groups becomes smaller and they become narrower, f also becomes larger. Our statistic f represents a ratio of the variance of the means over a number representing the variance within the individual groups. The further apart the means are, and the narrower the groups are, the easier it is to distinguish between the groups and the larger the value of f. F has a probability distribution associated with it. In this graph, we can see that there's a region that if f is large enough, we can be safe in saying that the means of the groups are different rather than being from the same population. Our lab exercises this week, we're going to use the F statistic to determine when we can distinguish between means of 3 or more groups. In this chapter, you'll find a demonstration of using Excel to calculate the F statistic, or analysis of variance. You'll also find a demonstration of using SPSS to do the same thing. You'll also find exercises for you to try on your own in class. The data sets for these exercises and the solutions are posted on Blackboard. Be sure to try out the examples yourself before you go to Blackboard to download the answers.